Hello everyone, welcome back to my YouTube channel. I'm Kirti from Sri Venkateshwara College of Engineering. Presently I'm pursuing my third semester of CSE Data Science. Today I'm going to give a presentation on the basic principles of ANOVA. First we have to see the introduction part. What is ANOVA and why we require ANOVA? So here is the answer for that. ANOVA stands for the analysis of variance. It is a statistical method used to analyze the difference among the group's mean in a sample. ANOVA tests whether there is no statistically significant differences between the means of the three or more independent groups. It essentially compares the variance between the groups to the variance within groups to determine if the differences are observed among the groups and means are likely due to random chances or if there is a genuine effect. ANOVA provides an F statistics, which is the ratio between two variances. The variance between the group means and the variance within groups means if the variance between the group is significantly larger than the variance within groups, it suggests that there is a significant difference among the group means. ANOVA can be used in multiple fields, including experimental psychology, biology, sociology, and economics, to compare the mean across multiple groups and understand the sources of the variability of data. Basic principles of ANOVA. The basic principles of ANOVA includes variability, null hypothesis, F statistic, significance testing, multiple comparisons, and assumptions. Variability is a fundamental concept in ANOVA as it determines the entire analysis. ANOVA assesses two types of variability. Those are between group variability and within group variability. Between group variability refers to the differences in the means of the groups being compared. It measures how much the group means differ from each other. In ANOVA, this variability is compared to the variability within each group to determine if the differences among the group means are statistically significant. Within the group variability, it is also known as error variability or residual variability. This refers to the variation within each group. It measured how much the individual data can points deviate from each respective group means. In ANOVA, this variability is responsible to the random variability or noise within the data. The basic idea of ANOVA is to compare the magnitude between group variability to within group variability. If the between group variability is significantly larger than the within group variability, it suggests that the group means are different from each other in a meaningful way and there is a likely genuine effect. On the other hand, if within group variability is relatively large compared to between group variability, it suggests that the differences among the group means could have occurred by random chance and there is insufficient evidence to reject the null hypothesis of significant differences. Null hypothesis. In ANOVA, the null hypothesis is typically states that there is no significant differences between the means of the group being compared specifically. It asserts that all group means are equal. For example, if we are comparing a effectiveness of three different treatments for a medical condition, the null hypothesis in ANOVA would be that there is no difference between the effective among three treatments. Mathematically, it can be represented as H naught is equal to mu1 is equal to mu2 is equal to mu3, where mu naught is the null hypothesis, mu1, mu2, mu3 are the population of the three different groups. Rejecting the null hypothesis implements that evidence. It suggests that the least one of the group means it is different from others, which indicates that there is a significant difference between the groups being compared. However, the important to note that rejecting the null hypothesis ANOVA doesn't directly specify that which group means the different from each other. Additionally, post hoc tests or pairwise comparisons are conducted to check the differences among significance of groups. Statistics is a test used to determine whether there are significant differences among the means of three or more independent groups. It compares the variability between group means to variability within groups. The formula for the F statistics in One way ANOVA with K group is F is equal to fraction of text between the group variability divided by within the group variability, where between the group variability is the variation among the groups means calculated as the mean of square between groups. Within the group variability is a variation within each group calculated as the mean of square within groups, and K must be a number of groups. The F statistics is follows as the F distribution under the null hypothesis of there is no significant difference between the group means. If the F statistics is large enough, it suggests that observed differences among the group means are unlikely to occur, the chances of alone leading to the rejection of the null hypothesis. Determine whether the F statistic is statistically significant. We can compare it to the critical value from the F distribution at the given significance level. Critical value, it will reject the null hypothesis and conclude that there are no significant differences among the group means. Otherwise, the calculated value is less than the critical value. It failed to reject the null hypothesis, indicating that there is insufficient evidence to conclude that there is a difference between groups. Significance testing in ANOVA. Significance testing in ANOVA involves the determining whether the observed difference among the group means are statistically significant or they are have occurred by random chances of alone. This is typically done by comparing the calculated F statistic to the critical value from the F distribution as a chosen significant level, commonly 0.05, which is 95% of significant level. Formulate the hypothesis. To start the null hypothesis and the alternative hypothesis, we have to check whether the null hypothesis usually exists. If null hypothesis exists, there will be no significant differences among the groups. Whether it is rejects the null hypothesis, we can conclude that there will be a chances of occurring of the significant difference among the each groups. For null hypothesis, we can use the formula h naught is equal to mu1 is equal to mu2 is equal to mu3 exceeds to mu power n. Alternative hypothesis h1 is equal to mu1 is different from others. ಯಾರಪ್ಪ ಇಷ್ಟೊತ್ತಿನಲ್ಲಿ After checking the hypothesis, we have to calculate the critical value or compute the F statistics. After calculating the F statistics, we have to determine the critical value. Looking to the critical value from the X distribution table, we have to use the statistical software. The critical value depends upon the chosen significance level within the degree of freedom associated with the numerator and denominator of the F statistics. After that, we have to compare the F statistics and the critical value. If the calculated F statistic value is greater than the critical value, we have to reject the null hypothesis and conclude that there is a significant difference among the group mean. If the calculated value is less than the critical value, then we can fail to reject the null hypothesis, indicating that there will be no insufficient evidence to conclude that group has the difference. After that, we have to interpret the result. Based on the outcome of the significance test, we have to interpret the results. If the null hypothesis is rejected, further analysis may be conducted to determine the specific group means that are significantly different from each other using the post hoc tests or planned comparisons. It's important to note that rejecting the null hypothesis in ANOVA does not provide information about which specific group means differ from each other. Additional analysis such as post-hoc test are often need to conduct to make such a comparisons. Comparison procedures are used in ANOVA to compare the means of multiple groups when overall ANOVA test indicates that there is no significant difference among the group means. These procedures are necessary but because while ANOVA can tell us where there are the differences among the group means, if it does not specify the specific group different from each other, multiple comparison procedures help to identify these situations. We have some multiple comparison tests such as Turkey's test as well as Bonfroni's corrections and do not test, etc. Ensure the validity of the result. Violation of the assumptions can lead to incorrect conclusion and the interpretation of the ANOVA. The key assumptions of ANOVA includes independence of observation, normality, homogeneity of variances, and homogeneity of regression slopes, and continuous dependence of the variable. It is essential to access the assumptions before the concluding of ANOVA to ensure the validity of the results. By seeing all those things, we can conclude that the ANOVA is a statistical method used to compare the means across the multiple groups. Its basic principles include assessing the variability between and within the groups, formulating the null hypothesis about the group mean equality, calculating the F statistic to test for the significant differences, and employing the post hoc test for the further comparison if needed. ANOVA relies on the assumptions like normality, homogeneity of variances, and independence of the observation, which should be evaluated before the analysis. By understanding and applying these principles, ANOVA enables the research to identify and interpret the meaningful differences among the group means in their data. By saying this, I would like to end up my video. Thank you one and all for watching my video. Please do like, share, and subscribe.